domain and range, let's see if we can find a domain and range based off of a function. Determine the domain and range. Okay, so here we have part A is f of x is equal to x squared plus 1. All right, so keep in mind, this is a review of what we already know. So looking at this function right here, we should already know what that graph looks like. What is it? Yes, good. It's a parabola or a quadratic. Sometimes it's called a quadratic or a parabola. The shape is that U, right? It's that parabolic shape. Okay, so now if I'm looking at my domain, then what values are going to work for this? Do I have any restrictions on my x? Ooh, that does bring up a good point, right? Okay, what are the restrictions? So what are the common restrictions? Oh, I don't know if that were restrictions. Oh, it's happening. It's happening. Common restrictions. Ooh, go back. For domain. All right, what are some things that would be a restriction for domain? 0 in a denominator. Good. So if you have something that's rational, if it makes a 0 in the denominator, that's out, right? Denominator. Good. What else? Yep. There it is. Okay, good job. Negative under a radical. And even, right? An even index. So an even radical. If I have an odd root, like a cube root or something, that's fair game. Yeah, but we can't have that imaginary as the issue there. Okay, so those are two common. Now, look at this. This polynomial right here. Does it have a denominator? No. That takes care of the first one. Do I have a radical? No. All right. So common issues associated with domain, we're looking for those denominators. We're looking for that negative under that even root. Okay. So here I have a domain is going to be infinite. Good. Now, what's the other thing we know about a parabola? Yep. So when I'm talking about the range, I have a space and then it goes from there. This is not going all the way down, right? It's not an infinite range. I go all the way to the left and to the right, so my domain is infinite, but not my range. I have to look at my vertex. Where is my vertex and what does that look like? So what is my vertex of this? 0, 1, right? Yeah, because there's a 0 here next to the x because it's like minus 0 and this 1 is in the back. So we know that that's a transformation shift up 1. Remembering this stuff? So I know that my vertex is 0, 1, meaning my range is go from 1 to infinity. Now, why am I going from 1 to infinity here instead of going negative infinity? Yes. Yes, good call. Because in front of my squared term here is positive. So I know that's going up to positive infinity. If it were negative in front, then that's where my parabola would point down and goes to negative infinity. Okay, good. Let's do more. Here's example 2b. Still we're finding the domain and range. And I have g of x is equal to the square root of 4 minus x squared. Oh, good call, good call. There is a radical. So when I'm thinking about my domain, I cannot have that negative under the radical, right? 0 is legit. Good call, good point. So I have to say 4 minus x squared has to be greater than or equal to 0. Yeah, because it can be square root of 0 is 0. That's legit. Good call on that. Okay. I have a quadratic with an inequality. So remember how you solve that? You find your critical points. Good. 4 minus x squared is equal to 0 for those critical values. Critical, that word is critical, contrary to what it looks like. Let's try again, shall we? Critical values. And so when you factor this, 2 plus x, 2 minus x, or you could do square root property, right? Add that x squared and square root it. I don't care how you do it. That's up to you. X is equal to positive 2 and negative 2. So on our critical values, then we graph that. Now, this is a negative quadratic. So there's a couple of ways to solve this. I don't care how you do this. It's up to you. If you pick values, oh, I'm going to plug a 0 in. When I plug a 0 into this, is 4 greater than 0? Oh, that makes my statement true. And because that makes my statement true, then I shade in the middle, right? You could do that. Or you could look at this and say, oh, I also know that this is negative, so I know it's going down. So if I look at end behavior on a polynomial, then I say, oh, where is my quadratic above the 0? Oh, it's above the 0 here, so I know that I'm shading between. I don't care how you do that. That's up to you. However you were taught, whatever you're comfortable with. I'm happy to go through that stuff even more if you have questions. Then you can do that. That's completely up to you. The fact that this is an or equal to situation tells me that I have brackets around that. So my domain here is going to go from negative 2 to 2. Right? Okay, cool. Now I'm looking at my range. So whenever I'm looking at the range here, I am saying, all right, for what values is my output going to be? So we also know that this is that quadratic, right? So here from negative 2 to 2, and I know that this is going down because that's quadratic. My question is, what is this top value? Right? Yes, it's going to be a 2. Good. And it's going to be a 2, and I know it's going to be a 2 because when I look at this and I say, okay, if I'm going from negative 2 to 2, and some of this stuff is just, hey, do I know information about this? Knowing previous information into the current lesson helps us out. From negative 2 to 2, I know I'm going to max out right here at 0. Look at what happens. I'm going to put it color on here. When I take this 0 and I plug it in up here. If I plug that 0 in, 4 minus 0 is 4, and the square root of 4 is 2. Do you see that? Because this is evenly spaced, I know this is a parabola, so I know it's going to be symmetric, right? Previous information into the current lesson. So because of that symmetry, I know that I'm maxing out here at 0. And at 0, when I plug that in, the square root of 4 here is 2. So I know that my range, and I can't go beyond that, so I'm stuck here, is going to go from 0 to 2. Let me go back to red. That's my range. All right. Okay. If this had been x squared minus 4, we'd be having a different conversation, right? Because it's not going down at that point, then it's going up, and then my graph goes off. But if it's x squared in the back, that's whenever it just stops from piece to piece. Okay, let's do one more. All right. right, so with example 2C here, again, we're finding domain and range. I'm going to have h of x is equal to x squared minus 3x plus 2 over x minus 1. Yes, good. We can't have that 0 in the denominator. Remember, we already talked about one of the pitfalls of domain, and that is one of them. So right now, I'm looking at this whenever it comes to my domain, and I'm saying x minus 1 cannot equal 0, so x cannot equal 1 because that is the value here. It can be anything else, just not 1. So from negative infinity to 1, and from 1 to infinity. Remember, you put those parentheses on that 1 because it's up to but not including. Okay. Now the question is, what's my range? Okay, well, let's check it out. If I'm looking at a range here, when you have a rational expression, you always want to see, is there something you can do to simplify this expression, right? If there's something you can do to simplify the expression, that is when you do that. And I look at this and say, we sure can. Wow, look at that right here. X minus 2, x minus 1. What happens when you can simplify out of the numerator? Yes, that makes a whole. If you can't simplify, then you're good. Your range could be infinite, depending, do you have any horizontal asymptotes? That's what you're looking at there. Here, if I have any horizontal asymptotes, or in this case, I wouldn't because the exponent's higher on top, right? Going back and remembering all that stuff. But the fact that I have a whole in my graph, so I really have h of x is equal to x minus 2. Yes, it is. That's totally a line, right? But don't forget, I can't have 1 here. Put a hole in my graph. So now I have to say, okay, that's fine. What is the y value that's associated with that hole? What is the xy coordinate associated with that hole? And that's my hole. When x is 1, because that's what makes my denominator 0, puts a hole in it, I plug that in and say, what's the y coordinate associated with that hole? And that's what makes my hole, right? So I've got this going along. I've got a hole, and then it moves on. So this coordinate of this hole here is 1, negative 1. Which means my range is going to go from negative infinity to negative 1, and then negative 1 onto infinity. So if there was no hole, then you would check for asymptotes, horizontal asymptotes, in order to determine if you're going to have anything there. Otherwise, then you've got your graph to be infinite. Okay, cool. Cool. All right.